Assalamualaikum and have a nice day. For today, we learn about 1.3 factors affecting reaction rate. Our objective today, at the end of the lesson, students should be able to explain the effect of concentration or pressure, temperature, catalyst, and particle size on the reaction rate. B. Illustrate the effect of temperature on reaction rate using Maxwell-Boltzmann distribution curve. C. Compare the curve of the energy profile diagram for a reaction with and without catalyst. D. State Arrhenius equation. E. Explain the relationship between temperature and activation energy to the rate constant based on the Arrhenius equation. We have 4 factors affecting reaction rate. The first one, concentration or pressure. The second one is particle size. The third one, temperature. And finally is catalyst. Concentration of reactants. Reaction rates generally increase as the concentration of the reactants are increased. The second one, temperature. Reaction rates generally increase rapidly as the temperature is increased. The third one, catalyst. Catalyst speed up reactions. And finally, particle size. The rate increase as the smaller the size of reacting particles. We look the first factor, concentration or pressure. Reactant concentration or pressure of gases is have a relationship with the ideal gas equation PV equal to nRT, P equal to N over V RT, pH equal to concentration RT. We conclude pressure directly proportional with the concentration C. Pressure or concentration increase, particles are closer to each other, more likely to collide, and have higher collision frequency. Probability of effective collision increase, more molecules with kinetic energy equal to or greater than EA, and finally reaction rate increase. Keep in mind, concentration change has no effect on zero order reaction. R produce product. From the rate law, R equal to K, concentration R exponent of 0. Rate is independent of concentration of R. The second factor is particle size. The smaller the size of reacting particles, the larger the contact surface area. Thus, frequency of collision will increase. Probability of effective collision also increase. Thus, the reaction rate increase. For the third one is temperature. As temperature increase, kinetic energy of molecule will increase. More collision occur in a given time. And then more molecules will have energy greater than activation energy EA. Effective collision will increase, and finally the rate of reaction will increase. The fourth one is catalyst. Definition for catalyst is a substance that increases the rate of chemical reaction without itself being consumed. A catalyst provides an alternative pathway which has a lower activation energy compared to the one without catalyst. Addition of a catalyst increases the reaction rate by increasing the frequency of effective collision. That is by decreasing the value of EA and correct orientation. For the effect of temperature on reaction rate, the effect of temperature on reaction rate can be explained in terms of kinetic theory. Average kinetic theory is directly proportional with temperature. The higher the temperature, the higher the rate of fraction. Maxwell-Boltzmann distribution show the kinetic energy distribution for a reaction mixture at two different temperatures. Okay, so we look for the diagram. Okay, so the first one, at the axis Y we have the mole fraction, and then for the axis X we have a kinetic energy. Okay, and then for the red color is referred to T2 is the higher temperature, and then the blue color T1 is referred to the lower temperature. Okay, when T2 more than T1, okay, actually at T2 is a higher temperature, molecules that have kinetic energy equal or greater than activation energy is more compared to T1, lower in temperature. The total area, okay, the total area under the curve equal to the total number of molecules. And then the number of molecules below both curves are the same. And then the shaded area represents the number of molecules possessing kinetic energy. Kinetic energy same or more than activation energy EA. Okay, at higher temperature, okay, T2, the peak, the curve moves to the right. Okay, the curve flattens, and then the more molecule with higher kinetic energy KE, larger pin shaded area, this one, and very few molecules have low and high kinetic energy. And at the high temperature, T2, particles absorb energy and become more energetic. More molecules possess kinetic energy equal to or higher than EA. And then finally, higher frequency of effective collision, reaction rate at T2 will increase. Okay, so conclusion, when high temperature, average kinetic energy of the molecule will increase. The number of molecules with energy equal or greater than EA will increase. Effective collision will increase, and finally rate of constant will increase. Okay, effect of catalyst. So energy profile diagram showing the different section in the presence of catalyst and without catalyst. So we have endothermic reaction. So energy versus at the axis X progress of fraction. So the red color EA with a catalyst and the blue color EA without catalyst. And then we have delta H equal to positive. Okay, in the presence of catalyst, EA is lower. More molecules have kinetic energy equal to or higher than EA. The probability of effective collision also increase. Thus, reaction rate will increase.